Hello and welcome back. In the past couple of videos, we focused on graphing sine and cosine with changes to its amplitude, its period, its midline, etc. Okay, and in this video, we're finally going to get into graphing tangent. Okay, and we're going to do this the exact same way that we graph sine and cosine. We're going to unwrap this unit circle. Okay, so I got 5 trigonometric equations, I guess you could say, down here. Let's go ahead and evaluate them, and we're going to use these values to actually plot the graph. So tangent of 0, well, that would be 0 over 1, which is 0. Tangent of pi over 4, so notice I am going by something a little bit different than when we did sine and cosine. Make note of that. Tangent of pi over 4, well, that would be root 2 over 2 over root 2 over 2 once you rationalize these, which is 1. Okay, now tangent of pi over 2 would end up being 1 divided by 0. We cannot divide by 0, so that's actually undefined. Okay, and tangent of 3 pi over 4 would be root 2 over 2 over negative root 2 over 2, which would be negative 1, and tangent of pi would be 0 divided by negative 1, which is 0. Okay, so these are some values. Now, when I go ahead and plot these, so we had 0, 1, this does not exist. I'm going to just put like DNE for does not exist, negative 1 and 0. Now I can actually continue this, and notice how I'm going by pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. If I wanted to, I could keep going, and what you would end up seeing is the same exact pattern emerging. You would see the exact same pattern emerging. Okay. Now, I'm going to go ahead and plot these. So I have 0, 1, negative 1 for y. I'm going to go ahead and plot these. So pi over 4, pi over 2, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 3 pi over 2. I'm actually going to go backwards as well. Negative pi over 4. Negative pi over 2. I'm going to stop there. Okay, I'm going to go ahead and plot these. So we had 0, 0. We had pi over 4, 1. This did not exist, and we were dividing by 0. Now, those of you that are familiar with rational functions, remember, whenever we tried to divide by 0, we ended up with a vertical asymptote. So we actually have a vertical asymptote at pi over 2. And then we're down here at negative 1, 0, 1. And then we are undefined again. It did not exist. We were dividing by 0. So once again, we would end up having a vertical asymptote. And I can continue this pattern going the other way. And what we're going to end up seeing is we're getting really close to this asymptote. And then we're going through these points. And this right here would be one cycle. This is one pattern. So notice this pattern is much different than with sine and cosine. We don't see a maximum. We don't see a minimum. We don't see it just going up and down over and over and over again. Well, I mean, we kind of do, but not in a wave-like structure. Okay? We see it looking almost like a cubic function. Almost like a cubic function, except it's bound between two vertical asymptotes. And that's what the graph of tangent is. And I can continue this, and this would be another cycle. Okay, and I can continue this in each direction forever. And we get these values by going around a unit circle the exact same way we did before. So let's go ahead and take a look at an animation. So as you can see, as we go along this unit circle, we're getting that curve, okay? We're getting that curve. And notice when it approaches these pi over 2's right here, we got 1 pi over 2, 3 pi over 2. We're getting an undefined, which means that we end up with a vertical asymptote. Now, you don't see it plotted here, but you can see it getting split up. And this would continue in this pattern forever in each direction. Okay, now that doesn't mean the domain is actually all real numbers, because if you notice, for all the odd multiples of pi over 2, that's where vertical asymptote occurs. So unlike sine and cosine, the domain is not all real numbers. It's all real numbers other than the odd multiples of pi over 2. Okay, so that is how we get the graph of tangent. And there's also some more differences with tangent. Now, before, with sine and cosine, we had maximums and minimums. We had defined maximums and minimums, but we don't see that in this particular graph. Okay, so one thing that tangent does not have: tangent has no amplitude. It does not have an amplitude. So if you're ever asked what is the amplitude of this tangent function, there is none. Okay, and that's because there is no max, there is no min. Remember, amplitude was half the distance from max to min. Okay, since there isn't a max and min, there is no amplitude. Instead, it's just our normal transformation. We just say that it's vertically stretched. We just say it's vertically stretched. We don't have an amplitude. Okay, another thing that's a little bit different here. Okay, is notice that one full cycle only takes a length of pi now. So the period for this tangent function is actually pi. Sine and cosine always had a period of 2 pi. Its parent functions had a period of 2 pi, and then we had to alter it. But tangent has a period of pi, which is going to change how we find the period for a tangent function. Okay, the midline, it's not like a midline like we normally think about, like we kind of normally see, but we can still think about this graph being kind of split up by a midline. Okay, so let's go ahead and take a look at how we can determine what all these values for a tangent graph are going to be. So when we have a tangent function, so just like we did in the previous videos, I have some constants here, a, b, and k. Now remember, there is no amplitude. A is not the amplitude because there is no amplitude. Instead, it is just vertically stretched or compressed by the absolute value of A. Okay, so it's not amplitude anymore. It's just back to our normal transformation talk, vertically stretched or compressed by the absolute value of A. If it's, say, 3 or 7, or if A is 3, -4, 15, whatever, that's vertically stretched, okay? If A is something like 2/3 or 1/2 or -1/4, that's vertically compressed, okay? And remember, if A is negative, all that means is that it's reflected over the x-axis, okay? Now the period, instead of being 2 pi over b, it's actually pi over the absolute value of b. Now, with sine and cosine, the period of the parent function was 2 pi. That's why it was 2 pi over the absolute value of b. But with tangent, the period is actually pi, so that kind of holds true here. Now, the x scale, we find the exact same way. We just take the period and divide it by 4. If you look up here, the period was pi. We went by pi over 4. We just divided by 4. Okay, and once again, the midline is once again y equals k. That k value, once again, is shifting it up or down. So if it's shifted up or down, it's also shifting the midline up or down. Okay, so that's how we find all of those values. All right, so I'm going to stop right here, and in the next video, we're going to go ahead and take a look at some examples of graphing tangent with all 3 transformations happening. Okay, so make sure you stay tuned for that.